Hello, welcome to Menlo Research Forecast. Today we invited Prof, who is a professor in NUS at a human-centric robotics lab. So, Prof, could you please give us a brief introduction about your career journey and also your research interests and what have you been working on in your research labs?
Yeah. So hello everyone, I'm Fan Shi, and now I'm a assistant professor in NUS. And my research focuses on robot learning for embodied AI applications. Especially, we are super interested in how to smartly leverage synthetic data towards robot learning, especially to humanoid robot. So in the past 2 years, I think our team make a lot of low-level or fundamental contribution in your system data in order to trigger lot of new possibility or even some high-level impacts on the application set. And for more details, it's like we read a very new simulation from scratch, from very low level, because our philosophy is like, if we do not make any fundamental breakthrough, we cannot, it's not possible to make a high level breakthrough, because for high level, if everyone uses a similar API, it's very hard to make something super new. Okay, so go back to our work. We are very interested in how to make a humanoid, it's kind of general purpose robot, to be more functional, more useful, maybe more safe towards the deployment of the real world.
I see. Thank you. Quite interesting about like the definition of the of your development, the general purpose of robot. And I notice in your labs page, you wrote that you want to develop robots' intelligence and safety. Could you please give us more like clear clarification for how do you think is robot intelligence and what is safety? Is it like interactions with human, or is it robot robustness and yeah.
Yeah, sure. It's a great question. So for intelligence, I think it's like how to make robot more functional. For safety, still in this field, the definition is not so clear. For ourselves, our definition is two sides. So first side is like the safety of the robot itself. So it's more like a robustness of the proposed controller or the decision maker. So for example, let's say the humanoid robot as an example. It's like we do not want robot to fully learn to, to destroy itself. And this is strongly related to how robust your EAI method algorithm or controller, like how robust it can be. And the meanwhile, on the other hand, is also something very important. It's like people surroundings, of the base robot. So most of our recent work is like we collaborate with Professor Chichia working on software material. We try to think of how to leverage a software material combined with this very rigid robot and to make robot to be more safe when doing the interaction with around the kind of big human. So in summary, it's like I think the safety part is like we hope a robot itself to be more robust in a real world deployment, and meanwhile in some worst case still trying to be safe to the surrounding and environment, because we believe this actually prevents the robot to be on the large scale deployment here real world. So that's some very important public for researchers like us should try to solve.
I see. As you mentioned, you want to like enable the robot to have a robustness, and also you mentioned that you're developing the simulation to generate like good semantic data. You can share with us more details about it. Like what are the considerations you're bringing into the simulation? Like what are the lack of the levels of the current simulation, and also what's your opinion about Synthereal? Because as what I have known, there are like a few different ways. They are like collecting data directly from reality and train the model based on that, or you can get like free data and in simulation, but however you have to fill the Synthereal gap. I wonder what's your opinion about this question?
The central gap is definitely a very serious and a very important problem to prevent the robot could get a lot of free or very cheap data from simulation. So first I want to share some successful example, and even I will share some still maybe not work about some 3 years example. So but successful example is like recently like humanoid robot was like the cardiac robot. So due to this, we have recently there are very nice simulation, especially from the NVIDIA, like the NVIDIA Isaac, the people Joko from Google. So for this kind of test, we call context sparse because usually, let's say your robot dog, maybe just 4 points for most cases to interact to solve this contact problem. So the context still very small scale. And for this small scale contact, actually, nowadays the simulation can produce very decent result very fast. And this success actually triggered a lot of our exciting progress in Humanoid, in Robotics. Let's say it could be Unitary or in Boston Dynamics. So we see the robot can dance, can fight, can do a lot of cool stuff. Actually, all is built by its 3D simulation. Okay, so this is a very successful case for EAN. But meanwhile, for more complex case, for example, let's say the manipulation, or we call contact-rich test. Like, for example, you want to brush something, you want to fold the clothes, you want to clean the bed, and so on. And still within so many companies here, maybe hundreds or thousands of people try to collect data from real world, right? So I mean, collecting from real world actually works for some problem, but NUS still have strong limitation to prevent to be scalable just because the cost is so high. It's like we need to have so many people to collect in real world area speed and this kind of issue are really serious. But why they do this? The major reason is like, I think I learned about the train simulation, but just because for many tasks, still our simulation is context-rich test simulation, not Friday. So it's just like the C2 population. Okay, we train this simulation, but never work on real world. Then this behind is nonsense. Okay, so people say this is a problem, but for us, we see it's a big opportunity because if we can create very high quality and cheap data in our CSEC data engine, there can be a big change. It's like we exist big swing low level to take a lot of new possibility for a high level application. We can make a data collection PPT 100 times cheaper than before. So for this purpose, actually our team, we spent almost 1.5 years to build everything from scratch. So this way, especially thanks to all my student, my postdoc and my PhDs, they work very hard to build everything from super low level. Here, low level means like we just write based on C++ CUDA, so we do not just say we leverage another simulation API. It's kind of too fake. So we write everything from scratch. We reorganize the mathematics, we reorganize the algorithm to make it super friendly to the GPU parallelization and email very fast. Okay, so the good news I want to share is like after all this hard work and the last month, we are very proud to represent AUS to show a live demo in the US booth. So in that demo, we show the only leverage data for our specific data for our simulation, and we can successfully zero shot to simply to deploy our humanoid robot. So in the triple A, we show we can continue to fold the tower for more than 1 hour. So this is a very challenging test. So that most people still need like say human calibration and so on. But for us, it's like we only need one single consumer level GPU to draw 15 minutes. It's just like you draw some electricity, very cheap compared to this kind of highway, your data fraction. And then we can deploy a very robust policy is a failure recovery with analysis. And then we have the courage to show the lifetime to like anyone to witness the success of it. So yeah, so this is very exciting moment for us. So but still go back to the question about Sync2 we think Sync2 still there's a lot of issue, but we believe for especially for some high value tasks, we believe as long as we work very hard in fundamental breakthrough, fundamental technology, we can trigger a lot of new possibility for these high level applications.
I see. Thanks for sharing. And I totally agree that the scalable is very important. And since you can like simulate, but like getting free data in simulation and improving simulation is definitely a better idea than collecting very high costly data in reality. But I also have a few questions about this because I noticed that there are some recent work about reality sim, which they samples the noise from reality to simulation to make it more real. And also along the way of developing our open source humanoid, we noticed that sometimes there are like multiple solutions, not just like perfectly simulate the physics in simulation, because sometimes, for example, the robot themselves can be like as a black box. You never know how much delay the motor has, and you don't know like what is the motor's performance, like uh, the motor at the torque and temperature curve along the way of using it. And also there are some recent work like iGen from Tsinghua University where they leverage the data from videos and like simulate the robot in the videos. I wonder what's your opinion about this?
Yeah, I think real world data is very also still very important, like real to sim to real. So I want to talk about our philosophy about real to sim to real. So actually for our simulation, we also will need some few data from real world. So for simulation, I think a good thing is like, okay, for real world data, we can calibrate the simulation. And then it's like you just need few data to calibrate simulation. And then you can use simulation to generate more branch of the diversity data. But meanwhile, it also somehow maybe follow the real world patterns. So I think that's a power of the simulation. It's like a bit to not simulate say, no, I don't need it ID robot. No, that's not the case. Okay, we need the real world data, but we always need it. But we just try to reduce the number of the how many bit data we need. But meanwhile, for a scalable part, we do not rely on real world data. For scalable part, we rely on your simulation data. And your second question also mentioned about your open source humanoid robot, right? Also, I always like to see it because I also very like to follow this kind of exciting progress, especially for Singapore. So from my experience, it's like it's always important to how to make a simulation more realistic because robot learning, no matter which method you use, you train from simulation, you train from real world data, it's all about we need a high quality untreated data, right? So high quality data is always a first priority. If the data itself is wrong, it's not really high quality, the robot learning does not make any sense. But you will learn something not so useful for you. So back to your open source not case, my experience is like still we need to very carefully try our best to to calibrate its motors, to calibrate its parameters, and once we can calibrate very well, we can really improve the quality of our simulation. But meanwhile, simulation data, to be honest, it will always have some mismatch and gap with the real world. So we always no perfect model. I mean, not only robotics, in physics, in chemistry, or if you have no perfect model, a model still can be functional. So, so for Centurion, one solution is like we try to make simulation more realistic. A second solution is like based on that, we can introduce more random validation. We can introduce more kind of different scenario to try to cover all maybe potential cases in robot will be. So I think we do need the two strategy together. A better segregation in motor, in environment, in context. And meanwhile, the very smart is kind of like a dominant ratio or some other techniques to make your policy more robust to against this situation mismatch.
I see. It's like trying your best to like map the simulation in reality. Like for the path that you cannot cover, you just try to make the policy more robust to generalize.
Exactly. Yeah, from the engineering perspective, that's kind of the most successful way.
I see. I'm very curious about the contact rich task we were talking about. Like because I noticed like the research work I've seen is mostly leverage like learning from demonstration or like the visual policy or like train on supervised training. I wonder how to design the reward in like with RL because I think the dynamic is quite it's not as intuitive or straightforward as working correctly if I'm wrong. So I'm curious, how do we do this?
So that's also a great question because my research actually, I start from locomotion to manipulation. And when I do locomotion, people, I mean, maybe 5 years ago, 10 years ago, people say, oh, locomotion and manipulation is a immense problem because locomotion we also call self-manipulation. It's like yourself to, to manipulate with the ground to trigger you how to walk forward. For manipulation, looks like, just a say. But actually, well, with PhD, I already did a work, try to use a robot dog to do some very fancy manipulation, whole body manipulation tests. I realized once it's just actually a question questions that I found the manipulation reward design is much harder than locomotion. The reason is like locomotion usually they have some pattern. Let's say maybe a human is not so obvious, or animal is more obvious, like a dog be just cooking easily. You have some decent gait, maybe we say the chop gait or some other gait. So this kind of pattern already provided very mass proven knowledge, and also you can learn for practice. Yeah, river design as well. And meanwhile for locomotion, we just follow some specific speed. Let's say you draw maybe 1 meter per second, 2 meters per second, so on. So much easier to design compared to writing activation test. For manipulation, the difficulty is like it's very hard to introduce this kind of prior knowledge. It's very hard to define what's the gate of, we actually have finger gate concept, are still very hard to, to as simple as a commotion does. Okay. So I think this also the real world data can play a very important role is like how to get for gas policy, how to determine better report. And meanwhile, mediocre about like for us and the national reward model. We also have some specific study on the reward modeling, which is like a leverage of very large model, even foundation model, just to give you performance how good this performance is, how bad the performance circle. So for manipulation, there is also some related research how to leverage some large model as a reward modeling to do it. So in summary, I feel like still reward is a very challenging point. So now we have a simulation, it's great, but then the second challenge is how to design very best reward towards this. So yeah, that's why it's also I think the fundamental level is still a challenge of the searching problem. It's actually how computer science area busy is problem. You have so many different solution, different strategy, how to efficiently search a optimal solution based from slightly heterogeneous space.
I see. As you mentioned, like you leverage large language model to like help to like reinforce learning with manipulation. I wonder how does a structure or architecture look like? Is like as a like high level planner, or it's something that like directly modify the reward functions?
Yeah. Great question. So this is actually one of our ongoing work, and I can share some insight. It's like, for example, imagine we are folding clothes, right? So actually, your photon foundation model, it can give you some like reward we call progress. From after we folding a whole task, maybe the progress is one. Then let's start with progress example. So the foundation model can actually based on your the very nice semantic understanding and also your general knowledge and common sense, they can actually output quite well for this progress. So this progress can get us from or below maybe in this way we feel maybe our life goals maybe it can improve the progress to be much larger, which means it can more closer to finish its test. So this kind of progress can be already nice and strong build signal to get how to your action will take. Meanwhile, maybe if we do something wrong, then the progress suddenly drops because to influence. So this kind of progress is a very nice guidance to create some very dense work to finish a test. And this is one reward, and another reward is like for termination reward. It's like, okay, I just want to judge whether you're a success or not. So that's a second. So in practice, actually, we need to combine these two rewards together. So we need to dance reward certainly where the combination with its success or not success is even more important.
I see. I'm also curious, like you mentioned that you use foundation model to as a purpose, but what if like it's I mean to me, correct me if I'm wrong, it's all like a judge to the like the RL, like whether or not you are doing correct or whether or not you are doing wrong. But is there a more clearer like instructions or something for the RL to really follow? Because sometimes if you just tell it if you fail, if you're doing not good, or if you have to achieve next goal, like what are the intermediate sort of instructions for the RL to handle this?
That's a great question. So I think for this one, we also need to maybe make some improvement in our part to make more, maybe add more semantic understanding of this test. So currently for normal reinforcement learning algorithm, it's like they only care about how to optimize the rewards. So it means I do not have any understanding of the semantic part. I just want to understand how to make my final cost function as large as possible. So yeah, so I think you asked a very good question. In this one, still we need more studies, especially how to leverage this domain either to and
I see. Yeah. And regarding to this, I wonder what's your opinion about like what is the final answer, or maybe not the final answer. What do you think is a more preferred model to do this kind of tasks? Because we know there are VLAs, which is leveraging the generalizability from the VLM, and they can do a lot of novel tasks. Though I heard a lot about things about its like real generalizability if you lack of good qualitative data, and there are also RL as you mentioned. It's more it's sort of like a hierarchical structure, if I understand it correctly. Like so it Leon is like end to end, and this is like hierarchical. Like which way do you think it's a future direction?
that I think that's a great question. I think so reinforcement duty is also into it. And the difference with VLA for the most cases is actually they do not have a language modality. And this may also also work to how to combine VLA based reinforcement like CV NTO as a bit with work. So go back to VLA. So and also I think still the important part is like how to get lot of high quality living very cheap data, right? So VLA now the problem is like I mean you have more dimension, you have more quality, also means you need more data. If you don't have enough data but you have a huge model, then it's very hard, to train this model to perform the test better. So for me personally, I am very curious to see how we can further push forward the VLA because it should be maybe include some pre-trained language patterns inside. So for this, may also introduce to see, for example, our simulation can generate data high quality with very cheap data, right? We inject this data into VLA to make the VLA training cost much lower than before because pure space, like people need like so many hours of your human calibrate data, right? So this one we are also very curious about. So for reinforcement, pure space works super robust compared to ELA. I think the reason is like the reinforcement, especially you train with in simulation, yeah, you have more data and also you have more targeted data. If a reinforcement always want to maximize, and if you make the site very smartly, we are always trying to solve the path which you not solved yet. So means you have very targeted data, and we will do risks. So we can introduce out of affordable failure recovery case. It will try to coverage all the potential failure. So that's why it's quite robust in many tasks. So for very if we can also have this tons of the failure recovery data, and I believe will definitely will be much stronger than current portion.
I see now. Understand more like of significance of developing the simulation as
Yes,
a way to.
we can have lot of tons of this kind of failure recovery data for simulation. From time operation, I think very hard for even you turn to it to do it, but still very hard to simulate all the possible cases for failure recovery.
I see. I'm curious, but I think I sort of know from like your like our discussion. But what's your opinion about like robot learning? Do you think like in very high level way of thinking, do you think robots should learn from its own experiences, or it should like learn also from demonstration, or it's like more of hybrid approach about it?
Yeah, that's also great question. I think also related to some cognitive research. For my perspective, also maybe from the first principle, let's just observe how human learns, right? I think human is also a combination. So we do observe some expert how to do that, right? We do observe our parents how to be cook, how to do something. And also we do, it's like we learn by ourselves. We like, okay, we do observe something and then we also got to trial and errors to improve our own skills. So for myself, it's like, I also as a researcher, I've seen it's great to be open to do not say no to any kind of data source as long as this kind of data is where it can be useful for your robot to, to master a skill, to be more robust, more reliable. Your robot, I think we welcome all the kind of data. Even if we do a lot of simulation, but you say we do not say no to real world data, we do all the data can be calibrate our situation. Here are some future real world data can also suggest the policy could be more robust or even continuation. So in some ways, for me, like philosophy, it's like I need to be more open to all the possibility as long as they can make a learning more reliable, more stable, and even more scalable. We should welcome this kind of data source.
I see. Yeah, I agree. We need to be very open minded of all the approach and like get all the pros of all the approach and leverage them together to make us better platform or like a way to train the policy.
Yeah. For me, that's also a cool part of robotics because robotics is in the end is to solve the problem. It's like I just only care about which method is best to solve the real world problem. Yeah.
I see. About like you mentioned you think we like as a way to think like hybrid approach of leveraging the demonstration data and also like the experience of like from RL. I noticed there are recently very great work about this paradigm where like beyond mimic they leverage like the motion like reference data from a lot of offline data set, and then you are able to give like a like for a motion retargeting, you're able to like feed the RL controller what is the like the correct end effector positions, also like the drawing angles for you to like follow, and then it's more intuitive to design the reward to like follow these motions while you have like task specific rewards. Um, but I'm wondering how do we better like leverage the benefit from RL, which gives us more generalizability because it defines a goal and it will try its best to finish the goal. But we also have benefit from the imitation data because it gives you like a little more clear instruction where you should go. But I noticed in like locomotion, like full body locomotion tasks, for example, you are lifting up a box, but you have to be very specific of the imitation data so that you generate the plan from the very beginning of the task. But to me, it seems a little bit fragile because the plan has already been made, and it doesn't have an interactive way of like teaching the RL policy to do any sort of adjustment along the way. And also, if I have data, motion retargeting data for like lifting up the box in a very specific position, how can you leverage the learning from this and transfer to other tasks, like very similar tasks at let's say lifting a different size of box or in different angles, which is the way I think how we human beings learn. Because we learn like your parents used to you should like bend your body down and lift the box here. And then you learn how to adapt to all of the scenario that's similar to this. I wonder how do we solve this problem.
I think you asked a great question. I think can be a very nice PhD thesis as well. The question is still about how to. I mean, we have a lot of human data. How to make to train a more versatile robot controller to leverage this data. So first, I think currently still it's very challenging. So there's many reasons. So one important reason we found is like still there is the strong domain gap, or we call it embodiment gap between the human data and the human non-robot data. So the domain gap will actually influence love because from both for some trajectory, which is the trajectory here means the Jones trajectory. The Jones trajectory is very optimal maybe for some human. Meanwhile, we found maybe it cannot be transferred to the human robot because they have different maybe configuration. They have different how strong your motor is, your accurate release. So it will really influence a lot. So I think this will already kind of prevent models, direct transfer between these skills. As second is also, I think, a simulation. Yes, maybe so many different tasks. Although we have so many different skills, but how to generalize to this kind of different tasks. So this was still very, very difficult, and we do not have a nice clear answer by the committee yet. So now that even beyond Munich is still, and that is very specific for specific tasks. It's not a general to maybe different one. Okay, so but here actually we found text is like real facility is still very popular about it. You give a perfect example for both. I think maybe with human robotics we learn maybe some trajectory to flip a box, right? But every time the box have be different from your demonstrate data. So here the real facility can play a very important role. It's like how to adapt to different data. Maybe I also try to use maybe the human demonstration as some work start, or maybe as some reference to have different way to like this see to the cost function. Yeah. So for summary, I feel like it's still a very doable direction how to smartly leverage this, prior knowledge from human, but we will not to be bothered by this because it's not it's like a suboptimal solution for human robots or for robot itself.
Maybe if it's too like specific, maybe just like overfit to the demonstration. But if it's too high level, maybe the RL controller wouldn't be able to understand what they were trying to tell me to do.
Yes, exactly. Yes. So, I think nowadays, I think people, I mean, for future, I believe, so if we can have some very nice simulation, we can, try to give a lot of different tasks. I think people already try to do is like, from a give 10 tasks, but what if we give 100 tasks or even more? A purely trained simulation. Could they somehow maybe, just like DeepSeek, DeepSeek actually also use every brief with many to help to trigger a lot of like chief thought or some high level intelligence. Could we also trigger robot agent to achieve such kind of ability? I see that for me, I'm very looking forward to see it.
I see. That'll be fascinating.
That's it.
And also you mentioned like from the very beginning, we talk a lot about like the robustness and generalizability. And like as in safety, you also mentioned like how the robot like, it's also a capability of the robot to interact with its surroundings. May I know like what sort of models or what sort of like high level learning insights you can talk about? Like does it have like awareness of its surrounding there or avoid the obstacles?
Okay, so for this slide, I think our first some highlight insight in what we have is like, so for hardware, it still need auto improvement. So nowadays people feel like, oh, looks hardware is great, we just improve AI, that's all, right? But actually, we for the hardware still have so many space to be improved. So for example, we could manufacture already maybe you touch or you see, for example, like unit tree or you post pandemic. We see all the robots are made by metal, right? Very sharp, very and also a little bit dangerous. But for human beings and for many animals, actually, it's a combination between soft and rigid.
Bones and muscles.
Exactly, bones and muscles. So for hardware itself is basic still we need lot of improvement before we really hope the robot and human will coexist in singularity. It's robot only maybe make the need to care. But for example, more and more tests actually a robot human coexist actually a couple robot to help the everyday people to take care of them, to take care of patient. So for this we believe hardware require more and more improvement. And there should be more and more sensors like for tactile and so forth. So still for hardware we still have a lot of improvement space to improve. And if we make the hardware even lesser, actually we can reduce effort for software. For example, imagine if we can build a much safer, the hardware part that maybe we do not need to consider too much on the software. So I think this actually deeply coupled with each other.
I see. I feel like I'm very biased toward like the software, and I feel like I didn't pay much attention to the like mechanical design about though. But I feel like it's very insightful that we also should care about the mechanical design, because that's what like takes all of the models together, and that's the like the core embodiment of all these things. That's the beginning of all this thing. Yes. And also regarding to this, I also know that I want to know what's your opinion about what should be like the correct or ideal embodiment for robot, because now we are highly developing humanoid and the quadruped, because they're very like bio inspired, and whole world and whole society is designed for humans, and a lot of tools we're naturally adapted to them. But also I was thinking, but I know there are some like Korean humanoid company where they build a humanoid where you can just bend down and become a wheel-based robot, which gives you a lot of like flexibility to switch between these two. Like for example, you go up the stairs, you can use your legs, and if you take a flat terrain, you can just use the wheels. Um, I cannot help I can't help start thinking, are we sort of constrain ourselves into like mirroring how real human is without like thinking about the possibility of maybe leverage something new or something more capable that like evolution is limiting human from. So and yeah, I wonder what's your opinion about it.
Yeah, so I think nowadays actually there is some shift from the specific machine to the general machine. So for example, 5 years ago or even 10 years ago, people care more about the specific machine, and also specific machine make it a great success, especially industrial. If I say for measurable arm, you have so many different types, and for a reaper, for the ending factor, actually for different types, you have some specific words to make your test more efficient. Just because at that time we do not believe, or maybe we do not think about how AI or intelligence can become so powerful to make the general ability. And recently, due to the success in ChatGPT, like this kind of the large foundation model, it's really give us some confidence or some hope, like really soon, the general ability will also come to the body AI, can come to the robotics. So that's why recently we have more and more debate whether we can build this general purpose robot
So specific.
that is our test specific. So my own opinion, maybe I think maybe next maybe 3 or 5 years for the industrial success, maybe still will mainly for the test specific robots. Meanwhile, I mean, for research, we are not just say, like say 3 or something like that, kind of see it's like 5 to 10 years. So for 5 to 10 years, or even after 10 years, I'm strong to be world with general purpose robot. And there's two reasons. So first reason is like I feel like only the general purpose robot can have largely reduced the price of the robot, because general purpose robot means like everyone or for lot of scenario we just use the same robots. Right? It's like you can manufacturing the same robots for very large scale. I think just like the car industry, and only this way they can greatly reduce the cost to make a robot, or affordable. And then meanwhile, most of bots is need more to common.
I see.
So that's the first reason. Still because cost, because robot is trying to solve real world problems, so we have to consider about cost. A second reason is like, so for general purpose robot, it's like, we have some randomness, general purpose robot or platform. It's like everyone is actually working on that platform. So it's like we kind of try to, converge or try to gather all the efforts together. Yeah, I could strongly believe this kind of robot will, the technology improvement will be even more speed up to make it more functional at the venture. So this are due to these two reasons. For long term speaking, I'm strong believer of the general purpose robot.
I see. And by then we just have a unified like your role. No, not unified. Like we have one humanoid and we can deploy different models for us to do like different be advertised to into different tasks. I see. Very like classic.
Yes, and maybe every customer can share the developer cost to make matter for many like tests.
I see. Thank you for sharing. And I know like what's the future goal of your lab, and also if you're hiring someone, what are looking what qualities or
Yes. So first, we are always looking forward to the genius students or the collaborations together to make sure embody AIs, to make robotics more excited, to make more functional, more practical, real world. So for myself, for PhD student for postdoc, I'm really looking forward to the strongly self-motivated students and also the student with some diverse background. So for example, in my group, I see we have a lot of students that be many mathematical background. For both some students strong in simulation, some still strong in reinforcement, some strong in hardware, some strong maybe in some learning part and so on. Because I see nowadays only if we have some very multidisciplinary team that people with different expertise, they can couple together to generate even some more grand ideas. Okay, so for diversity and for self-motivation, I think it's first very important. A second, we also encourage students to be very professional. So here, actually, we realize it's like because some students, it's just come from the college. Some students actually from some academy, from industrial. We feel like they both have some, and it has different kind of advantage. Always see some good characteristics. For people from the industrial, we also very impressed by their professionalism, especially from how they deliver for their research. Meanwhile, how to they for work with their cost management. And another thing is very interesting. I feel like many of them they have very strong and very clear motivation. It's like being industrial, they already say, oh, what's a kind of limitation, what's a real problem. Then I decide to go to PhD or some really part-time PhD, able to leverage academic knowledge to try to solve this problem. Yeah. So this summary is like we strongly motivate the student. This dream is you have your own dream, but for me, my job is to try my best to provide results to supporting dream.
I see. Thanks so much for sharing and giving us this fascinating report. Very perfect. I wish we can collaborate or like have more interesting discussion in the future. I wanted to.
Thank you very much, really, to talk with you. Thank you.